In question 9, the diagram shows triangle ABC with AB equals to BC, which is equals to 6, and angle ABC is equals to 1.8 radians. The arc CD is a part of a circle with center A, and ABD is a straight line. In part A, we have to find the perimeter of the shaded region. So the perimeter consists of the straight line BC, the straight line BD, and the arc DC. Now, we already know that the line BC is a 6. To find the length of BD, we need to find the length of AD. Now, AD will be equals to AC as they are both the radius of the circle. And to find the length of the arc CD, we'll have to apply the formula S equals to R theta. So for that, we'll have to find the length of AC. Now, as two lengths and the angle between them is given, so we can apply the cosine rule to find the length of AC. So AC will be equals to 6 squared plus 6 squared minus 2 into 6 cos of 1.8. So 6 squared plus 6 squared minus 2 into 6 cos of 1.8, and then taking the square root, that will be equals to 9.40 centimeters for the length of AC. As AC and AD are equal, so we'll write AD will also be equals to 9.4. So as the length of AD is 9.4 and AB is 6, so the length of BD will be equals to 9.4 minus 6, which is equals to 3.4 centimeters. To find the arc length of DC, we'll apply the formula S is equals to R theta. Now to find theta in this triangle, we know that this is an isosceles triangle, which means that both of these angles will be equal. So we can write 1.8 plus 2a will be equals to pi radians. So to find theta, we can write 1.8 plus 2a will be equals to pi. So a will be equals to pi minus 1.8 divided by 2. So pi minus 1.8 divided by 2, the angle will be 0.6707. So a will be equals to 0.6707, or we can write it as 0.671. Once we have the angle 0.6707 or 0.671, the arc length will be R, which is, so the radius of the circle with center A, which is the length AC. So the radius is AC. So AC was 9.4. So this will be 9.4 multiplied by 0.6707. We always take the complete value when we are calculating and then round off in the end. So 9.4 into 0.6707 will be equals to 6.306. So once we have all these three lengths, we can find the perimeter by adding the length of BC, which is 6. So this will become 6 plus 6.306 plus the length of BD, which was 3.4 centimeters. Adding these three up, the perimeter will be equals to 15.7 centimeters. In part B, we have to find the area of the shaded region. Now to find the area of the shaded region, we can find the area of the complete sector and then subtract it from the area of the triangle. So the area will be equals to area of sector minus the area of triangle. Now to find the area of sector, we'll apply the formula. So area of sector will be equals to 1 upon 2 r squared theta. So the radius of the sector was 9.4 centimeters. So this will be 1 upon 2 into 9.4 squared multiplied by theta. So theta was 0.6707. Substituting this in the calculator, the area of the sector will be equals to, so 9.4 squared multiplied by 0.6707 and dividing it by 2, that will be equals to 29.6. So the area of the sector is 29.6 centimeters squared. To find the area of the triangle, so the area of the triangle will be found using the formula half AB sine C. The lengths are 6 and 6. So this will be 6 into 6 into the angle between. So the angle in between was 1.8. So this will be sine of 1.8. So multiplying 6 by 6 and then multiplying by sine of 1.8. that is equals to 35.05. Dividing it by 2, the answer will be 17.529, or we can write it as 17.3 centimeters squared. Finally, finding the area of the shaded region, we can just subtract the two areas. So area of shaded region will be equals to 29.6 minus 17.3. So the final answer will be 15.7 centimeters squared. Will be 12.1. So this will be 29.6 minus 17.3. That the final answer will be, so 29.6 minus 17.3 will be equals to 12.3 centimeters squared. Now, as I rounded off some of the values, this is not the exact answer as given. The exact answer was 12.1 centimeters squared. So this was the exact answer that was given in the exam, in the mark scheme. However, because I rounded off these values to one decimal place, so I got a different value. Now, giving this answer in the exam will result in a loss of -1. So it is better if we use the complete values when subtracting, when getting the final answer. Once we have the final answer, then we round it off to three significant figures.